Or in the meantime, while Tom is organizing his desktop. Basically, what we are going to do is just a mini tutorial on some of the archetypes that we do have for generation of ONOS applications. That's basically enable you to develop an application in a faster way with just auto-generated standard code that has to be there for it to run with ONOS.
So since we have, this is actually a variant of a talk which was designed for a little bit of a longer period, but since we have only 30 minutes, we cut out the front part which shows you how to deploy actually cluster from just a tarball file, as Brian was mentioning. So we skipped that part, and so what we're starting with is basically a running environment. But before we get to that portion of demonstration, let's talk about a little bit some of the theory. So ONOS applications are effectively built, they're built on OSGI. They're built and they incorporate not only just OSGI itself, but also some of the Karaf container-specific features, specifically the feature functionality, which allows one to deploy a collection of bundles together as a single feature. So ONOS built on top of this. We didn't want to reinvent the bundling mechanism or anything like that. We inherited straight from OSGI, and we didn't want to reinvent the feature mechanism that Karaf has to be built on top of both of these things. What ONOS does add to the picture is the distributed aspect, because Karaf is a single sort of JVM, but ONOS is a multi-JVM, multi-node system, distributed one, and since it's a symmetric one, as I mentioned earlier, it needs to make sure that the symmetry is maintained with respect to applications as well. And so if one installs an application on any node in an ONOS cluster, we need to make sure that the application also is installed everywhere throughout the cluster before it is considered installed at all. And so we've essentially introduced the notion of an application, which is backed by one or more Karaf features, which then in turn are backed by one or more OSGI bundles. And we've introduced essentially a lifecycle for an application. The application either does not exist at all, and then so to state transition from non-existence into existence is installation. So you install it, and now the application is installed. Once it's installed, which means that it's actually everywhere in a cluster, only then it can be activated, which means actually the code is then ignited and loaded into Karaf as a set of features, and then activated as a set of bundles that are now running, and actually there is life as far as the application is concerned. Of course, once the application has been activated, it can also be deactivated, in which case it's completely withdrawn in terms of its running state from the OSGI container, but it's still present on the disk, and ONOS still knows about it so that it can be reactivated again. Of course, to sort of wipe it out from the system entirely, you can uninstall the application, in which case it ceases to exist, at least as far as that ONOS cluster is concerned. We have, to manipulate this, we have a ONOS CLI, UI, as well as, of course, REST API to be able to do these things. So today, what we're going to be talking about is developing the ONOS applications using specifically the Maven archetype, as Andrea mentioned, and also as Brian alluded to, in the future we will provide archetypes which can be built not only using Maven but also built using Bug. So this is a simple visualization of the fact that applications can take on many different forms. It can be as straightforward as a single bundle with a feature file and then application description, or it can be as complex potentially as basically multi-bundle, multi-feature entity. Again, just with more application description file. Majority of our applications actually today are either this or that, because as you look at the source tree, most applications which actually want to facilitate interaction with other applications will usually provide an API bundle and an implementation bundle, so that the API bundle can be something that can be exported for other applications to depend on and compile against. So this is actually probably the most predominant variant of the applications that we have in ONOS. What's not shown in here, which is something that we plan to do, is to provide even a simpler packaging model, which is basically a single bundle which contains in a manifest all of the necessary metadata that currently app XML and features XML carries. So it can actually be very, very concise form of packaging, which is just a plain jar with extra metadata in manifest. So as I mentioned, today applications are then delivered using this ONOS application archive, which is basically a jar which contains all of the items that I've shown, other bundles, manifest, feature manifest, or app manifest. Well, I believe I've covered it actually. I didn't realize I had it here. You can use REST API, you can use shell tool that we provided, which actually wraps the REST API, and there is also commands to manipulate by CLI and UI. So there's a number of different archetypes which can build different flavors of applications. Some of these archetypes are overlays, which means that actually they can lay on top of an existing project to provide customization. So for example, let's say, well, I want to develop an application that has a UI and has a REST API, but I don't care about the CLI. Well, then what you do is you build an application, you create an application, and then over top of that, you will overlay the UI and REST API archetypes. And then you can just customize the code that has been sort of provided as a template for you. So today, what we're going to do is basically create I'll show you how to work with these archetypes. For that, we're going to use the following environment, which is actually located in Menlo Park. We have a VPN connection to it, which comprises of 3 ONOS nodes, a network node where we're simulating Mininet, and of course the laptop, which is this machine right here that I'll be operating while Andrea provides a narrative. Okay, so we're gonna develop an application of our own. Of course, you may ask what application. We're gonna develop a one-ping application. Have you seen Red October movie?
Yeah.
All right. So we're gonna develop an application that's gonna allow only one ping between any 2 hosts. Of course, these are RCMP pings rather than SONAR pings. We're gonna spare you the video. We don't have appropriate audio set up to fully convey the metaphor. So I'll be typing while Andrea will be speaking and letting you know what to do.
Yes. So we're gonna just start with the minimal command that provides you the features to create the bundles and the palms and the files for your own application. So can you
let's do that.
Okay. So it's just ONOS create app, and that's the command, and then you have to specify the app because this is the starting point. It has to be like, for example, if it was CLI, that's going to be CLI. And then it's org.oneping because we want our application to have that Java package, and one ping as the name of the application, and 1.o-snapshot because it's the first version of our application. We didn't change it. It's just the first one. Okay. Yes,
good, right?
It's good. So this generates. It's the name of archetype. We just confirm all what we said before, and this generated us a bunch of files, specifically the pom.xml for the application, and then some Java classes. And now we're actually going to import the project into IntelliJ. So we can show you how to easily import a project. One ping pom.xml, just do that, and you import the whole project into IntelliJ. And this, once IntelliJ just loads a little bit, okay. So you will see that we have test class and the app component. That app component is actually the one that's doing the heavy lifting and doing the actual work. The test is a unit test. Now, for demo purposes, we're gonna just not do the unit test, but you should do it because you should be a good programmer. And but we're just going to delete it, and we have to change the pom.xml just a little bit. So these are the properties that are used in, for example, the ONOS UI that Simon demonstrated a little bit before. And you should specify your own company, the origin. Maybe you can specify your URL over there just for the wiki, for example. Just maybe a little different README, but it's fine. After that, we're set. Right now, we have no code in there, but we just want to show you that just with this, you can actually deploy it into an ONOS cluster. So we have to build it. So in the one ping folder, we just do maven clean install. We're not using but yet for the reasons that Brian illustrated to you before. So this is just building the application, and it generated the OAR that Thomas illustrated before. And now we have to basically install it into ONOS. And we're going to do that. So this is the OAR, okay? And we're just going to do that through the ONOS app command. This is a wrapper upon a REST call, and it's ONOS-app, then the IP of your machine, and that's our first machine. Very important thing, it doesn't matter if this is 1 or 2 or 3 in your ONOS cluster. It can be whichever of one of the machines in the cluster, because it gets automatically replicated to all the nodes in the cluster. So you put the OAR to the first node, and the other nodes get it from that node. So it's just install exclamation point. That exclamation point says also activate it, because you can just make it in a 2-step process and install it into ONOS and then activate it with other methods later. But this just installs it and also activates it. And then we just specify the OAR. So basically what this does is gets the OAR and pushes it via REST to ONOS. And now, if we go into ONOS, we're using the latest release version, that 171. These are the 3 machines that are running ONOS in our cluster. And you see, this is the cluster. So these are the devices that are managed, 31 devices, 108 links, 31 hosts. That's the Gian topology, by the way. And this is what we're using right now. And
you haven't installed yet, right?
Yeah, we didn't install it yet. So these are the applications that are running without our own. We're just running proxy ARP, forwarding application, the OpenFlow base, because we're using a Mininet simulated network. So that's how we simulate what we're going to show you. And the drivers application, just for somebody that was here for the Southbound talk before. So we can now install it and activate it at the same time.
I'm installing to the second one, just mini minimal. I chose the second one.
Just
okay.
It doesn't matter.
Doesn't matter.
Just because it's not a problem.
Okay.
So this is what we get back and saying, okay, we did it, now it's active. And if Thomas is using the same command, you can see our app here. This is what we just installed into ONOS. Install and activated. So this is all the apps that are activated, okay? These. Now, if we go into the Mininet machine, we can see that our application has no code into it. We didn't put anything into it. So if we do a ping between 2 hosts, H1 ping H2, hopefully this works.
We have 3 people when install.
No, it just host of each. Well,
yeah, we lost connection in between here and there, so I'm wondering what happened.
Just maybe redo Mininet attach. Just a little bit of debugging, so you see.
Reattach is
yeah, just close it and reattach it. So this is a screen of the Mininet topology that we are running. This is a Mininet CLI, and that's a machine that it's in there, but actually in your network, this is going to be physical devices and not Mininet.
Yeah, we're going to reconnect our network because our network got compromised.
Well, in the meantime, we should actually code the application.
Yeah, so let's start it up.
Let's set up. Did you do topology? So basically what we're saying now is use the topology of Giant comprised of those devices, those links, and those hosts to Mininet, and do STC net setup that brings up the network in Mininet. And these are things that come with the standard ONOS distribution. So these are commands that you can do it yourself at home. And so now we're actually going to probably code the application.
I think it was
What?
we lost connectivity.
Did we?
The wireless is off. No, but
No, we tried to get it. Yeah.
no, the VPN died. So it fails. Okay.
Just show it locally. Just run on instance locally. Show it locally. Show it locally.
Well, can't do that. Apparently, our connection to through the wall went haywire. So what we're going to do is we're going to switch things, and I guess we're not going to show it in distributed context, but we're going to show you how to run it using locally built. But we can do hotspot. Is it the VPN or?
Because this was in a distributed environment in Menlo, but you can run your local installation and do the same things. It's going to be a single node instead of multi-node because, well, these machines can support maybe 4 VMs to run the whole thing, but if you're developing, you need an IDE and all of that stuff. So it's better if you run a single instance. But a single instance, if you don't have to do replicated stuff, it's perfectly fine. And you can do a single instance, run and development on your environment, and then use a distributed system, the distributed 3-node cluster to test the distributed part of your application. We up?
Not yet.
Okay, so
I'm going to attempt.
Thomas is going to do is just resetting the environment that we are using. And this is just basically killing the ONOS instances.
Yeah, you don't have that.
Well, just use it locally.
Yeah. Okay. So forget that. So we're just going to run basically using buck.
Yeah, we build using buck.
Does 1.7 have Brian? Does 1.7 have support for ONOS? I don't know. Brian, does ONOS 1.7.1 doesn't have ONOS local, right? Yeah. That's 1.7.1.
1.7.1. So
sorry about that. It's running connected to by a thin tether to our runtime environment. Unfortunately, we're bit by this. It's going to take a long time.
Yeah. Did you have something already built?
When you're running through Python, we built locally. I downloaded it.
Yeah.
No. I mean,
should we just shoot?
Yes,
Just the link, just copy the code. So okay. Done.
so you only want to demonstrate.
Yeah, just copy the code inside the Java file.
Okay.
So we're actually demonstrating building with buck and running with buck. Processing the buck files, building the thing, and just more or less what Brian showed you before. It's going to be a complete build because it's 1.7.1 and Tom usually develops on the master branch. That's what we do.
Yep.
And so it's just pretty fast. Building applications right now, BGP, ISIS, Southbound. It'll take a minute and a half to build the whole thing from scratch. And this is what you're going to do if you download the bits and build it with buck. This is the thing. And after that, just gonna run locally on Thomas machine. So it's ONOS plus probably a mininet VM that we have.
Oh, I mean, the unfortunate Murphy strikes.
So right now, this is also packaging ONOS because we needed to run it. So this is the log, graph log for ONOS. And it's starting up, so you can see also that, and we can attach a CLI on it, so we can see what's local. And so this is running on this machine right now. So this is a new session on graph here that's authenticated on this address, and this is the session. So these are the applications that we are running right now. That will be a little bit more than what we had before. It's optical bundles. So we can do the same thing basically with our one ping application to the local host. Instead of setting an IP here, we can just do 127.0.0.1 or localhost. And we activate it and send it to the localhost machine, and there it is. So remember, there's nothing here.
The problem is I don't have a ready to go virtual machine.
Machine.
Because I was not counting on running it like that. So
yeah, but
we can. So the problem. Okay, so I guess we can't demonstrate the live code, unfortunately, because our runtime environment connection has collapsed. So, but what we can still do is how to.
So you just now this you see is a template. There's nothing in there, but the method that you need to deactivate the application, SGI, and the log, because you need the log just for this. And it is a component, as Thomas demonstrated to you before, and immediately 2 minutes it starts up immediately when it's activated. So we can show you, this is the one ping code that we actually have somewhere else, and we can just put it here and just go through it a little bit. So basically, this is not important.
We need to call this.
Okay, so here you can see some interesting stuff. Basically, here we're referencing to other components in the ONOS code base and in the ONOS runtime environment. So here it's the packet service, flow rule service, flow objective service for anybody that listened to Brian's talk before, core service. So this, when the application gets loaded, can actually automatically get binded to the instance of these things that it's already running into the ONOS code base. Okay, and then there's the app ID. That's the unique identifier of the application into ONOS. And so this is where the code. This is actually the intelligence of our application, among other things. But now in the activate and deactivate method, we're actually registering the application with the name. Say basically what this is just telling the core service, hey, I'm a new application. Just this is my name inside ONOS. And then we're adding the processor for the packets inside here. So basically, when a packet comes in, we see it through these packet processors. And you can also have priority in this packet processors. So this.
Oh, sorry, this is I want to generate one. My bad.
Yeah.
Let me go back, but actually, this is the one that's going to be on that packet.
Yeah, this is the one. It's a packet processor. That's something already defined in ONOS. We're just extending it, overriding the process method to implement our own thing. And so basically, it gives a context, the packet context, and the ETH that's Ethernet, and it gets it from the context itself. And we're keeping a ping record for basically seeing when the ping is already pushed between two hosts. Sorry. And maybe the flow. Should we show the flow rule?
Sure. So yeah. So, for example, yeah. Let's say we wanted to ban a ping, right?
Yeah. This is how we ban a ping. Basically, you get the device ID, MAC address, source of the ping and destination of the ping, and then you build a default traffic selector on matching the Ethernet source and the destination source to a builder, and then basically you say drop it. You need the traffic treatment to drop the packet, and then you're asking the flow objective service, Northbound talked still before by Anton, to basically have these elements with a selector that we defined before here, with the treatment that we defined before, some flags, the priority we defined as a constant before, we make it temporary. So basically you could say this rule is valid for 10 seconds, 20 seconds, minutes, hours, you specify it here, then you call add, and what the flow objective does is actually put what we told him to put here inside the devices through OpenFlow in this case.
Our original goal was to actually not to do a code walkthrough, but to show you a live demonstration. But unfortunately, because it fell flat on its face due to environmental issues, we figured we'd at least show you some of the at least nature of the structure that applications.
But maybe for somebody of you is more interesting the code than seeing a ping not going. So, and this is actually, if you want to check out the code and try it for yourself in your environment, this is part of the ONOS samples repository. So you just go there, the code is already there, so you just don't have to create it yourself. And well, that's basically it.
That's it, yeah.
Let's see if we had any other slide to show.
We actually have a recording of this session working from, was it from ONS?
Yeah, it was from ONS.
Yeah, so there's a recording online of the similar, actually extended demonstration that shows this live, unfortunately.
Can you go back to the slides?
Yeah.
And these slides will be made public, and just a couple of pointers that I wanted to show you the last slide. So, wiki, this is the tutorial. This is the video that Thomas was referring to you before. This is the one that we made at ONS this year, and we had a local environment, so it worked perfectly. And this is the template application tutorial on the wiki. And if for anything, we're available these 2 days, and also via email. It's just simple as that. Tom@on.lab.us, Andrea @on.lab.us. Just get it there. That's it. Do you have any questions, guys? Yeah. Oh, yes, sure.
Maybe we need as well to show how, in fact, you can collaborate with a group for developing one application, let's say. So, because some people maybe are use different, let's say, code management versions like Mercury or Git, etc. So how to make, let's say, very simple, but a full collaborated application, like for instance this stupid
the one ping.
Yes.
Yes. So we use Git, and we use Gerrit for reviews, but you can actually download the review from Gerrit. So that's the easiest probably thing. Somebody develops the application, pushes the initial release to Gerrit, and the other collaborators can download it from Gerrit or plain as or Git. So we use Gerrit, and we use it for development also, but underlying all this is Git. That's what we do.
No, that's right. I mean, clearly, I mean, you can use whatever source control system. If you're developing an application that's outside of our source code base, you can use whatever source code management system you want, or whatever collaborative scheme you want.
And finally, to publish it to the community, you need
So I mean, clearly, for certain ONOS applications, we will just let, especially if they're smaller or if they appear to be if they have a very wide appeal, then we would probably just host them under the ONOS source code tree. But if there's larger project or incubating projects that tend to bring larger amounts of code, then would we probably encourage the creation of a separate repository. It can still be hosted under the whole ONOS project name, but it would be a separate repo with its own, and it's still can go through the Gerrit review, same portal of Gerrit, And then once the application stabilizes and matures, as part of that maturity, you would then bring it back into the ONOS code base. The reason we're doing this is because, you know, sometimes you have applications that sort of are there's concepts that maybe sometimes will never mature. And the problem with hosting those inherently immediately under the ONOS application tree is that it bloats the ONOS Git repository. You can't ever shrink it. And so that actually slows down the initial clone speed of the ONOS. So what we're actually considering is potentially splitting most of the applications out into a sort of separate repository. There's pluses and minuses to that. And I think Brian can probably provide more feedback on this.
But also every application that gets inside the ONOS repository and you get it when you download ONOS, that goes through Gerrit code review process because it has to adhere to a set standard of code quality. Because that's basically the code that we provide as ONOS, so it has to be properly done. And it's a fairly, I think, active community as for reviewers also. So, and we suggest anybody that wants to push code into the ONOS repository to push it to Gerrit first interfaces and then the actual code, so we can talk about the architecture before and then the implementation.
Yeah, we also like to encourage developers, whether they contribute code or not, but these two, because there's contribution that can happen on both code front, but also on the review front, or documentation front for that matter. But specifically, we're interested in contributions in reviews, where people can supply comments and their own sort of opinions and feedback on code that's coming in. Because the more reviewers there are, the more eyeballs on the code there are, and generally the code tends to be of higher quality. And so that's a huge help for us. Otherwise, the reviews have to be done primarily by the core team, and that puts a lot of time. And so, you know, Brian, maybe you can talk a little bit about the module on the program, right?
Yeah.
Yeah, sure. Mention something on that.
Yeah, maybe 3-4 minutes and then we're done.
Sure. So pretty much anyone who wants to and is willing to sign the CLA can contribute code. So Gerrit.onosproject.org is our main source of code review, one main portal for submitting code to the project. But what we've done is we've built out a program over about the past year where we have an incremental process for becoming what would normally be called a code committer. So typically in projects, someone who's reached a committer role has the ability to accept code into one of the branches in the project. What we realized is that there's a pretty high bar to gain mastery in the project and become a code committer. So we've introduced a program we call module ownership, where you can have committer rights in a small sub area of the project. And at this point, I think we have about 15 or 20 different module owners in various areas of the project. It can start with like just a single directory. And then as you continue to gain experience, that can grow to 2, 3, 4, 10, or the whole project. So you can either be nominated by a colleague, or you can nominate yourself when you feel like you've developed a mastery of a certain area in the code base. The TST will review any nomination, and then there's sort of a determination whether or not you're ready to tackle a certain area. But for people, as they gain experience in the project, module ownership has some benefits. For projects that you're working on, you have the ability to review your own code from peers, and make sure that it makes it into the project in a timely manner. For areas of the code that don't necessarily have active module owners, it can take a little longer to get code in. Yeah, we're actively trying to expand the program, and if you feel like you've been contributing in an area and want to sort of take on the next level of responsibility, consider nominating yourself for module ownership.
Thank you. I think that's it.
And in regards, sorry, the earlier question was about whether projects belong in ONOS proper or side. And I think the answer there is where you have codependency, where there's going to be development happening in the ONOS project and in your application together. it can make a lot of sense to host it in ONOS. Like Andrea was saying, it's got to adhere to our coding standards. It's got to make sure it builds and everything, but check style and unit tests but we do like to have a number of applications both as samples, demos, and stuff that ship with the product. So if you've got something that you're working on that requires code changes and you're working back and forth, the nice thing about having it in ONOS is that changes can be applied atomically. API changes in ONOS, and the reflection of those changes in your application go in one commit. You don't have to worry about managing versions between the two. If you've got an application that's entirely standalone that you want to manage, run, have commit access to, and test in your own ways, then it probably makes sense to have a separate repo. And as ONOS project, we have certain projects that have repos under our Garrett, and then there's also collaborators that prefer to maintain their own repositories. The advantage of having one in the ONOS project Garrett is it's easier for other people to discover the code. It's easier for people who want to contribute to your projects to do so. But it's sort of case-by-case basis depending on whether you're going to build against release stuff and some other parameters.
You want to speak more about for external apps, we want to encourage dependency on release versions.
Yeah, so as I mentioned before with ONOS app samples, we're actually actively under discussion of the release cadence. We're thinking about trying to publish the snapshot artifacts as release artifacts or beta artifacts more regularly, so that if you don't want to depend on master, you'll be able to depend on like a snapshot that occurs maybe every 2 or 3 weeks. So you can get new features. It's not going to be an official release yet, but it'll be a beta of the official release that you can start to build on and upgrade to in a more systematic fashion. So the idea being that stuff in ONOS project can depend on the more or less snapshot, up-to-date latest master. It'll break the build. The build will break if your app breaks too, which is kind of nice. But for external applications, depending on release versions is good. It provides a nice stable point for you. And then if you do need latest features, having those incremental builds is something that we'd like to do so that your apps can be built against.
When Brian says release version, what that means is in Maven terms, not in ONOS terms. It's not an official ONOS release, but rather it's a Maven release. It's a release. Those artifacts are released.
It's published
on the Maven Central.
Maven Central, and it's published with a version number that's going to not change.
It's a stable point in space.
Okay.
And again, apologies for the bumpy demo. As always, Murphy rears its heads. Yeah, do look at the video that has, has a broader spectrum of functionality demonstrated, and the functionality that we wanted to demonstrate here but couldn't is shown.
Yeah, we did also demonstrate debugging at that time because you can attach the IntelliJ debugger to any instance of ONOS that has the 505 port open, and just can debug, run through the code, and see what's the problem in your application using a distributed cluster of ONOS too. It's not a problem.
Thank you.
Thank you.